jhat juku.
Please hit subscribe.
This problem appears at the qualifying examinations for applicants for Japanese government or MEXT scholarships 2020. This problem is from the 2020 College of Technology Mathematics questionnaire. The answer key and the original questions are linked in the description.
We need to compute this definite integral. The first step that we will take is to compute the antiderivative of this given, and then use the fundamental theorem of calculus to obtain the definite integral. So we will compute the antiderivative and then plug in pi and negative pi. Here we will derive the formula for this integral, and related to this integral is this integral here. We notice that the only difference between I and j is that here we have a sine function and here we have a cosine function. Here we have an exponential function and here we also have an exponential function. So let us start with I. We do an integration by parts. If we recall, we know that this is the formula for integration by parts. This is from the product rule of derivatives. And so we assume that the given is in the form like this. And so the way we compute that is by computing this difference. So the first step would be to assign u and dv. Here we assign this to be u, and the remaining will be dv. So this u here is this, and dv would be this times this. And if this is u, then we can get its differential. This is what we get. And if this is dv, then v would have to be like this. Now we just plug in these values for uv and du into this formula, and this is what we obtain. Now we notice that this integral here is actually j. And so we apply another integration by parts on j, and this time we have these assignments. This is our u, and the remaining would be the dv. Again, du would have to be this, which is just the differential, and if this is dv, then we have this to be v. Now we just substitute these values into here, which goes into this bit here. And so if we just copy this entire thing into here, and then we replace j with the integration by parts, which is this bit, and so we get this. And we notice that this integral here is just I again. And so we replace that with I, and we do some simplifications. We obtain this. And we notice that we can now group the i's. We move this to the other side, and we do a bit of algebra, and we obtain this as the final expression for I. And now we can obtain j by, first we can do another integration by parts for this bit here, or another option is we replace the I in here, replace the I in here with this expression, and then we solve for this j. And you will see that we get this expression. Notice that I and j are very similar. This term here is the same as this. The coefficients m and n are the same. The only difference is that here we have a sine, then a negative cosine. Here we have a cosine, then a positive sine. Notice that here we have a sine, and the original integral also had a sine. Here we have a cosine, the original integral had a cosine as well. For convenience, let us call the definite integral I and the antiderivative f of x. Now we can apply our shortcut for f of x because we see that this form matches that of the shortcut. We simply take the e to the 2x outside, and the denominator we get the square of this plus the square of the coefficient here. Then, because this is sine x, we have sine x, we have minus cosine x, and then the coefficient here goes here, and the coefficient here goes here, and we have the arbitrary constant out here. So this is now our antiderivative just from the shortcut. Therefore, our definite integral is just f of pi, which is the upper limit of integration, minus f of minus pi, which is the lower limit of integration. We substitute this value into f of x, and this is what we obtain for pi, and this is what we obtain for negative pi. We notice that a lot of terms cancel. In particular, sine of pi is 0, and the cosine of pi is negative 1. And so this term here becomes positive 1. In the same way, here we have, again, sine of negative pi is just 0, and cosine of negative pi is again negative 1. And so this term here becomes negative of negative 1, which is just 1. And finally, if we simplify what we obtained in the previous slide, we get this. This is our definite integral. If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!
Please hit subscribe.